playing with this idea of just being in water, stuff like that going on. This is a situation where, again, you don't have a neutralization reaction. So you're not going to have this idea of like acid plus base or an acid with a nitrate. This is a bomb calorimeter problem, which is a bit different. I don't know if you're going to go through this. Hopefully you will later. This is like a second subtype of questions. So what you've got here is you've got lactic acid and it's burnt in a bomb calorimeter. You've been given how much you've been given the specific heat capacity, and it's not water this time, it's lactic acid, and you've got an increase of temperature. So you need to calculate the enthalpy.
Okay.
I feel like you're speechless.
Per gram, okay. And per mole, he wants both. Okay.
Well, we're going to do per gram because per mole is a bit harder. It's more uni based. But these are my uni questions, by the way. So you're not going to do per mole. We're just going to do per
gram. Okay.
All right.
So we're going to make our equation.
No, you don't.
Actually, no, there's nothing going on here. So it's just burning.
It's kaboom,
technically, there is an equation for combustion, but yeah.
Right.
Do we need it? No.
No. So I'm going to help you out. This is what you're having. So you're going to have delta, you're going to have C times delta E, which means you're going to do your specific heat capacity, which you've been given. It's not water. It's going to be
times out change in temperature.
That's what we're doing. Times the change in. Can you still see my screen, by the way?
Yep.
24.95 minus 23.10. Yeah?
Yep.
Perfect. That's going to give you an answer. I'll just do it so you can have, this will be like a tutorial.
Oh, okay. Yep.
You've had energy being liberated, so it's going to be negative because it's exothermic. So you've got 8.902. Do you agree with me, exothermic because it's combustion? Does that make logical sense? Combustion?
Yeah.
Then, yeah, cool. So it's going to be a negative Q. And in this situation, everything we've been calculating, can you see that the specific capacity has been given us in kilojoules per mole? Can you see right here?
Yep.
So that means our answer is automatically going to be in kilojoules. Because this is a question where they, for some reason,
now do you next have to times that by our grams, by our sample?
Close. You're not going to times, you're going to divide.
Divided by, okay, so you have your kilojoules per gram, per 0.
Correct, kilojoules per gram. Perfect.
Yeah.
So you're going to have delta H, right? You're going to divide it by this. You've got 8.09. Hello, can I learn how to type today? Yep. Kilojoules. You're going to divide it by the amount of grams, which it's been nice. They gave it to you in grams already, so you don't have to convert.
Yep.
65, and that's going to give you negative 15.18
kilojoules per gram.
So then we know. Do you want to do the mole section?
Yeah, it doesn't sound that hard. So now that we know that we have temperature, that's our kilojoules, how much energy 1 gram of that will burn? I mean, will make when it's burnt. Okay, that's a useful measurement.
Cool.
Like that could be useful for calculating your energy you're going to get from a lump of coal or something useful.
It has its applications. I agree with you. In the real world, it's not like algebra, which you don't use anyway, unless you're a mathematician or a statistician, which you're not. Anyway.
Or a chemist. There's a fair bit of there's some useful algebra.
No, it's very basic algebra though. It's like foundational algebra.
Alright. That's true.
Alright, so because we're on a roll today, I'm going to make you actually do the uni section, and we're going to work out also the moles.
Okay, so what else? Well, isn't that just...
So, let me just quickly help you out firstly. So moles, you know the formula is mass divided by molecular weight.
Would it by any chance be your joules over molar mass by any chance?
Very close, except it's not joules, it's the mass.
It's it's the mass. Okay.
Can you see my screen? Yep, you're good. So you're going to do 0.0 0.5865.
grams
Yeah.
over.
And I'm going to divide it by its molecular weight, which I can tell you we don't have time to be calculating, which is this.
Yeah.
Which you're going to get an answer of 6.5 times 10 to the -3 moles.
And then you put your joules over that to find your joules per mole.
You're going to use this one.
Yeah. Yeah.
So then, last step is you're going to do -8, as you said, -9.2, and you're going to divide it by the moles, which you've worked out here. You're going to work it out by that.
Yeah.
And you're going to get an answer of -1.367 times 10 to the power of 3 kilojoules, remember, because we've already converted per mole.
Okay.